So we're pretty familiar with using arrays. So an array say we're talking about an integer array. And we have values in these elements. Suppose that we want so there's numbers here. And suppose we wanted to insert a number into the list between 3 and 4. So we would have to take all of these elements and we'd have to shift them to the right. And then when there's a space for our new number, we could put that number in. So imagine this array is 10,000 elements long or 1,000,000 elements long. If we had to shift all those elements to the right, the longer the array is, the slower this process would be. So that's not a good thing, because if you had a very large array, all of a sudden your program could be running very slowly. So that is one reason to motivate the use of what's called a linked list. Okay, so a linked list doesn't use an array, rather it uses nodes. And so if we wanted to store this list, this sequence of numbers, we would put one of those numbers in each of these nodes. And the list is connected by references. Okay, so object references that we use in Java. So we have this object and it has a field called next, and that object reference points to the next node. Okay, and in each node we have data. In this situation, if we wanted to insert, let's say we wanted to insert a new node between these two nodes, for example, all you would have to do is get your new node, and simply change a set number of these references. So instead of this object reference pointing to this object, we point it here, and this one points here. So now we have an intact linked list, and the work we had to do to insert one item was very small, and it will be very small regardless of how long the linked list is. So here we have one reason to use a linked list or a linked list similar structure in our programs. Okay, so let's take a look at how we implement this in Java. We said we had node objects, so that means we were going to have a node class, and there were two things in each node: the data. In this case, I've chosen to make it a string instead of an integer. And we have an object reference that points to another node. So we have a node object reference inside of our node class. Okay. So it seems like there's a node inside of a node, and I suppose you might think of it that way: nodes inside of nodes inside of nodes. But it's better to think of it as a string, a linked list. Okay, so here we have a constructor. All it does is take some data and it initializes this field. So if we want to use this object, this class, we're going to create 4 objects, initialize it with some strings, and then what we need to do is connect the nodes so that they are in fact linked. Okay, so node 1 is going to link to node 2. So its next field needs to be the next node. node 2 needs to point to node 3, and so on and so forth until we get to the last node. The last node is not going to point to anything, okay? Now I could have left this line out and it wouldn't have made a difference, but I wanted to make it very obvious and clear that the last node doesn't point to anything, okay? So if I want to take the data and print it out, I can use a variable called current and set it to be referring to the first node. I can print out that data. And if I want to go to the next node in the list, I can say current equals current.next. So now I've kind of hopped over to the second node in my list, and then I can print it out. And I keep doing this, and along the way I get all 4 pieces of data, which are the strings. So when we run this, we get the 4 strings printed. Tiny bit of terminology here. The first node in a linked list is known as the head, and the last node is known as the tail. So we've got some diagrams here that show various linked lists using memory state diagrams.